Hello everybody, and today I will give you a simple introduction of Grandway testing meters. Grandway Telecom has a very rich testing experience in the optical network, especially in the FTTX last mile testings. We can provide the customers a complete testing solutions product. For example, as we all know, OSI layer has 7 layers, as the bottom layer is the physical layer. In this physical layer, we usually need to test the optical fiber power, fiber loss, and fiber length. So, we have some common products to test the power, like power meter, like laser source, like palm power meters. And also we have this selective power meters to test the 10G power network. And also we have this FHO 1500 optical explorer to test the drop cable quality in the last miles. And also we have this 5000 pound OTDS to test from the ONU directly to the OLT to finish the end-to-end fiber link test. We call it pound OTDS. And at the data link layer, we have some products like FOH100 series to test the PON ID and ONU serial numbers and the PPU accounts. And we have this FOH200 series can be applied for in the 10G and XGS PON network for the PON ID and ONU serial numbers. And next, we also have some products to work for the application layers. In this layer, we need to test the wireless and the Wi-Fi test, like PMT 800 PDA. This tester supports more than 2 gig download speed test compatibility. Also, this supports Wi-Fi 6 test. So, Grandway has a very complete testing solutions for the FTTX. The first part I will introduce is the physical link layer product. In this layer, we have some products to test the power level and the power loss and the fiber length, like this. And as we all know, this is the GPON structures. From the left to the right is ORT and splitter and ONUs. And we have this product, we call it 2P01. This product can connect in series to the PON link and to detect the upstream, like this, upstream 1310 and downstream 1490. And also, if there is RF video signal in the downlink, we can also detect and measure this power. The power is 1550. So this PON power meter is suitable to the GPON and EPON power level testings and supports measuring upstream 1310. This is the burst mode, and the downstream 1490 and 1550 CATV signals. And also, this PON power meter supports pass, warning, and fail indications. It will make the test more easy. And currently, the GPON network will be upgrading to the XGS PON. At this time, we can see the difference between the wavelengths. In the GPON, the downstream is 1490 and 1550, and the upstream is 1310. And we can check the XGS PON. The downstream is 1577. Here is 1577. And also the upstream changed to 1270. 1270. So we can see the PON link. The operator usually deploy the GPON ORT and the XGS PON ORT together in the central office. And they share, the GPON and the XGS PON share the same fiber link, the same ODN link. And at the end, depending on the customer requirements, the operator can deploy the GPON ORT or the XGS PON ORT. We call this network, we call it COBO. We call it COBO PON network. At this time, the downlink, there are 3 wavelengths together in downlink. And uplink, there are 2 wavelengths. So for such COBO PON network, we also have different products to meet the customer's testing requirements. Okay, for example, if the customer only want to test 2 wavelengths for the downlink, no need to test the upstream. Only for the downlink, we have this 2G10 to test the downlink for 1490 and 1577. This is the selective power meter. It can selective test the downlink power separately. 1490 and 1577. And if there is 1550 CATV signal in the downlink, we have another product, FHP 3G10, to test 1490, 1577, and 1550 together. Also, selective power meters. If the customer want to test not only test the downlink, but also want to test the upstream, uplink, we also have this product, 3P05. 3P05. This can test all these 5 wavelengths. All these 5 wavelengths together and show them together. So in this page, I introduce 3 products: FHP 2G10, only for the downlink, selective power measurements for 1490 and 1577, and the FHP 3G10 if there is 1550 IF video signal in the downlink. And also FHP 3P05 can test these 5 wavelengths together. There are 3 products here. And these pictures show the difference of the selective power meter and the broadband power meters. There is obviously 3 dB deviations. And then the left picture, this picture is the selective power meters. These power meters can separately the downlink signal, these 2 signals, and test them one by one. And this is the broadband power meters. They cannot separately test things. The test values is 2 power add together. So this value is obviously bigger than the separately value. So if the customer's network has been upgraded to the XGS PON, the selective power meters is a must for the power testings. Otherwise, if you use the broadband power meter, it cannot give you a correct reading. Okay, when we finish talking about the power testings, we talk about something about the fiber link testings. And we can know this is the PON network structures from the ORT to the ONU. And usually there are two splitters inside. And here is the feeder fiber, and here is the distribution fibers. If the customer want to test such fiber link, maybe total length, maybe total loss, like this, some customers will use the OTDR functions. But the OTDR functions has some limitations. And here, this pictures is the test screenshot of the OTDR functions in the PON network. We have some difficulties when using these functions. First one is complex OTDR curve testing settings. If this technician is a new guy, he maybe do not know how to set up the testing parameters, and so he will have some problems when do the parameter settings. And also when the OTDR trace is coming, he needs to analyze the trace and give himself a reading of how this 5-PON network it is. And also, in the OTDR mode, only one pulse width can be used. So, single pulse width maybe cannot give you a correct test results. This is the limitation of if you use the OTDR trace function to test such PON network. So, what do we have? We have these functions. We call it FLM. The total name is fiber link map. Yes, we call it fiber link map functions. This function is a way to farewell to traditional OTDR methods. FLM functions have some features, like these functions has a high dynamic range to pass through splitters to test from the ONT to directly to the OLT, from here directly to here. Also, it has very cool technologies. It is automatically adjust the multi-pulse width based on the fiber link. Multi-pulse width. Usually, this mode will use the small pulse width to test the fiber link from the ONU to this side. Before the splitter testing, it will use the small pulse width. And after that, it will use the medium pulse width to test this fiber link, pass the first one splitters. And at last, it will use a big pulse width to test from the ONU directly to the OLT to pass through two splitters. So, the core technologies is to use the multi-pulse width. This method will be more accurate to describe the whole PON network. And also, this test mode is supposed to filter the online service signals if the PON network is a live network. And also, this mode can have a very accurate splitter identifications. For example, there are 1x4 and 1x16 splitters. It can show you the splitter icons. And also, small data zone to detect the small events in the PON network. And also, accurate ODN loss from the ONU to the OLT, and the distance and the loss measurement is more accurate than the OTDR trace mode. So, this FLM is farewell to the traditional OTDR methods. And this is the field PON testings by FLM. And here we can see the pictures show there are two 1x8 splitters, two 1x8 splitters, and the total ODN link quality is good. And also, this is the PON testing by FLM functions. And these two pictures is tested at my home. And actually, there are two fiber link in my home. Both of them are from the China Telecom. And this fiber power signal is very good, maybe around minus 17. And this fiber signal is not very good. Maybe it's minus 20, 25. So I use the FAM functions to test these two fiber link, and we can see the test results very obviously. The left pictures, the fiber link quality is very good, show you the path and every events. First connector and the first splitters is 1/8, and the signal splitter is 1/8, and the splitter insertion loss is good quality, 10, and maybe it's around 10 dBm, and the total length is 3.3 kilometers, and this ODM link is very good quality, so it will give you a very good power. But this fiber quality is minus 25. I use this FAM function to test, and I found a lot of problems in the fiber link. This connector bad quality, this connector bad quality, and this splice point also bad quality. So this point cause my power is very weak. So by FM functions, we can clearly know where the problems happen in the fiber link. When talking about the FAM function, fiber link map, actually it is free software functions in our 5000 Pro series OTDR. It is just like the IOLM in the X4. But X4 is charged, but the Grandway's FLM is free. Okay, so next I will talk about something about the 5000 Pro series OTDRs. It is a new version. We call it Pro series. We do a lot of improvements in the last 2 years. So this Pro series has a good test performance, and some features like 7-inch touch screen, and the limit range from 26 dBm to 50 dBm. The maximum is 50 dB, and the small data zone. The minimum data zone is 0.8 and 3 meters. And also this supports the PON online testing modules, 1625 and 1650. Both are available. And also the multi-mode test mode is optional. And when talking about the PON test compatibility, this model, the maximum can test pass through 1/128 splitters. Also, this OTDR is a multi-function integrated. Lots of functions inside, maybe VFO, like stable data source, like power meter, like fiber link map, like fiber microscope, and so on. And these testers have RJ45 Internet cable, supports remote control on PC software via RJ45 cable. And also, the OTDR reports can be directly generated in the OTDR. PDF report. PDF report can be directly generated inside. No need to connect to the PC and make the report. And also multi-languages. And also Bluetooth and the mobile phone app is available on Pro versions. Bluetooth app means you can control OTDRs on the mobile phone app through the Bluetooth connections. Okay, when talking about our Pro version OTDR, we have some highlights. The first highlight is different models are available, and also we can design and make the new OTDRs according to the customer's need and requirements. We can do the customized for the customers. And I just list some parts of the models here. Like 5000, if you want to test the multi-mode, we have this 850 and 1300 nanometers to test the multimodal fibers. And also we have this model. This model supports single mode and multimode together. And these are some common models. This is just for the single fiber. Just the dynamic range is different from the D26, D35, and D45. Also, we have D50. D50 is also available. And here is the dynamic range. Is the corresponding dynamic range of each models. If you want to do the live fiber testings, we need to select these models with F, because F means filter. Filter. Here is the filters. Because we need to filter out the online signal, then we can do the OTDR testings. And also these models can be used for the power network and for the troubleshooting. This is the highlights. The first highlight is different models are available. And next highlight is the large dynamic range. And the left picture shows you the maximum test distance by our D45. You can see the total distance is here. This is the fiber end, and this is the fiber end distance is more than 200 kilometers. And this fiber spoons is in our Grandway lab, because not in the field, just in the lab testings. So this D45 can be suitable for the long haul fiber network testings. This is the maximum pulse width. Use the 20 microseconds pulse width to do the test. In the lab, we can more than 200 kilometers. In the field, it depends on the fiber quality. The test distance may not reach to the 200 kilometers. And the right pictures show you the testing in the field. This is the field testing. We use the 500 nanoseconds to test the 50 kilometers fiber length. And also we can see there are a lot of fiber splice points in the link. We use 500 nanoseconds. It is very easily to test 50 kilometers. And also we can see there is still a lot of fiber dynamic range to do the more longer test. So this is the highlights 2, large dynamic range. And the next one is the very short dead zones. Only 0.8 meters event zone and 3.5 meters attenuation zone. We can see here we set up a test environment. 2 meter patch code, 2 meter patch code, 2 meter patch codes, and it's the connector, and here is a 20 meter patch code, and in the middle there is a small micro bendings. And we can see the test result is the first 2 meters patch code, the second meter patch code, the third meter patch code, and from here to here is a 20 meters patch code, and in the middle there is a micro bendings. We can detect this micro bending very clearly, and we can see this micro bending is here is around 13 meters, and here is only 7 meters. So this micro bending is very close to the connectors, which means our OTDR has a very short attenuation zone, and we can see every reflection of the connectors only 2 meters From A to B, only 2 meters. Only 2 meters. Which means our OTDR has a very good event distance. So our OTDR has the ability to easy detection of 2 meters continuously patch code and fiber attenuation within 10 meters. And actually at this fiber, I also conduct 2 meter patch code, 2 meter patch code. And our OTDR also detected this 2 meter patch code at the fiber end very clearly. This is the highlight 3, very short distance. And the highlight 4 is very important features, optimized PON testing compatibilities. We have some PON series. PON series means with F and with 1625 nanometers. T40F, T43F, T45F. These 3 models we call it PON series, and these models can pass through 1 by 128 splitters very easily, with enough dynamic range and a small PON zone to accurately describe the overall structure of the PON network. For example, the test link is OTDR and 1 by 16 and 1 by 4 and ORT. And this is the OTDR trace mode. Trace mode, we can see this is the test results. The total length is 2.5 kilometers, and this is the first splitters loss, around 13 dB. And here is the second splitters 1 by 4. Here is this, and here is this, is 7 dB. Very accurate splitter insertion loss detections. And also, for example, there is 1 by 8 and 1 by 8 splitters, and also we can detect such PON network very easily. This is the first 1 by 8 splitter, and this is the second 1 by 8 splitters, usually around 10 dBm. This is highlights for optimized PON testing compatibility. And the next one is excellently FLM, fiber link map functions. This functions, the core technologies is to adopt multi-pulse width test mode. Users can automatically test without complex settings to get the most accuracy and the most clearly test results. The fiber link map mode will show you the icons, very clearly icons, not the trace. So we can know we can read the results very easily. Even you are new guys for OTDRs, you are become very clear about the fiber link. For example, here is the start point and 1 by 8 splitters, 1 by 8 splitter, and here is the splice point icons. And also this mode supports the pass-fail judgment. If one event the loss is beyond, it exceeds the threshold, it can show you the fail. If the loss is within the threshold, it will show you the green. Green means pass. And here, the splice loss is 0.7 dBm. This value maybe exceed the threshold. Usually for a splice point, the threshold is for 0.2 dB, so it can show you the fail results. And this function, we call it FLM. Actually, it is very similar to the X4 IOLM. IOLM is charged, not free. But Grandway FLM, it is free functions. But we have very similar testing performance with the X4 IOLM. These two pictures show you the comparison with the X4 IOLM. We can see the same first 3 meters. Second one is the 228, 28. And the third one is the 15, and the third one is 15. And the next is 27, 28. 1 by 8, 1 by 8, 1 by 8, 1 by 8. The test results is very, very same. Very, very same. Very close. The next one is the built-in PDF report and the Bluetooth functions. And this is the fiber link map report. This report can be generated directly in the OTDR. Built-in OTDR report functions. And also, it supports the Bluetooth and the mobile phone app. This is the 5000 Pro Series OTDR mobile phone app. You can use this mobile phone app to control OTDR, to do the testing setting, to do the fiber trace analyze, and also you can send the SOR files to the customers on the mobile phone app. This is the OTDR testing, this is the SOR check, and this is the transfer files. This is the mobile phone app screenshot. Okay, last we talk about the OTDR 5000 series. This is to test ONU directly to the ORT in the PON network. Next, I will introduce you FHO 1500 Optical Explorer. This product is mainly used in the job cable in the last miles. Job cable, we mean this from the distribution box to the ONU. Test this fiber link. Actually, the last miles in the FTTX. This Optical Explorer has some new functions, like the PON parameters. This supports test 4090 and 1577 and upstream 1310 and 1270 nanometer Cobalt PON power test. And these pictures show you the power test. For downlink, it can selective to test the dual wavelengths. And for the upstream, it can also test the 1310 and 1270 power level. And the next one is the weak light ONU link troubleshootings. Weak light ONU. What is weak light ONU? Usually, if the ONU's receiving power is very small, maybe smaller than minus 27, maybe smaller than minus 25 dBm, we call such ONU is weak light ONU. The weak light ONU may without the customer's internet experience is not very good. Sometimes the network service is not stable. So, in order to solve the weak light ONU problems, we have this product to help the technicians to do the weak light ONU link troubleshootings. And the three functions is ONU status identifications. If the ONU is online, offline, and sometimes it's actually no ONU, our testers can accurately make the ONU status identifications. And the last one is the 20 dB OTDR modules. This supports the 1650 wavelengths and support test more than 60 kilometers fiber length. Okay, the first functions is the weak light ONU troubleshooting. Weak light ONU troubleshooting. We just need to connect our testers at the splitter side. At this time, we can know the downlink and uplink at the same time. For example, we connect at this position. We can check the power level, downlink, and uplink, the power, downlink power, and also here show you the uplink 1310 or 1270 uplink power. And also, we can know this fiber quality, this job cable fiber qualities. If there is some fiber problems happen in this short job cable, our testers can give you a very clearly test the result. Actually, a lot of problems will cause the weak light ONU, especially some situations like the poor conductor status, like the conductor damaged or improper connected or dirty, or microbending, possible microbending in the job cable, and sometimes the ONU is not connected well at the job cable. A lot of problems may cause the weak light ONUs. So with our testers, we can know these possible reasons directly. And you can see this tester screenshot. Our tester find there is the microbending, very big microbending, cause 3 dBm fiber loss, and the position is 13 meters. So our tester can help to check the job cable qualities. Okay, this is the first functions of weak light ONU troubleshooting. And also, these testers can check the ONU and the splitter connection status. Sometimes the ONU signal is not good is because the connection status is not good. The connection status means the connection between the job cable with the ONU and the job cable connection with the splitters. Sometimes the job cable is not connected well to the correct splitters, like this. So our tester can help you to check the connection status. This picture shows you the job cable is not connected well in the ONU. Maybe the job cable or the ONU fiber interface is dirty, or maybe damaged, maybe the connection is loose. And this picture shows you the job cable is connected well on the ONU. No, so for these pictures, the tester is no problems. And also this shows you the job cable is connected well on the splitters, also no problems. If there is a red square, that means the splitter connection is not good. We need to check the job cable on the splitter side. The next function is the ONU status and notifications. Usually we can test online and offline and the no ONU status. We can see actually this is a function like the power meters. This is online. This is no online signals, so it is the offline. And this is actually there is no ONU disconnected. We use the OTDI technology to test such offline ONUs. If there is no upstream signal from the ONU, maybe the ONU is power off. Maybe the ONU is actually no ONU connected. Because the customers maybe use others operator, other carriers network service. So the customer do not use your ONU at all. And the next function is this Explorer. This FHO1500 Explorer supports the live fiber testings over 16 kilometers. Okay, next part I will introduce the power network testing solutions in the particle layer testings. In this layer, we need to test the PON ID and the ONU serial number and the PPUE account. This is some testing for the particle. And the first product is a PMT200 PON installation tester. These testers support the GPON ONT emulation, allows field technicians to troubleshoot and validate the GPON network installations from the PON ID and from PON ID analyze and the optical power reading and ODN loss. These aggregates. We connect our testers in the fiber link. We can read the downlink ONU receiving power and the OLT TX power, and to calculate the ODN total loss. To judge the ODN link is passed or not. And the most important is to detect the PON ID and the ODN class and OLT TX powers. And also it can show you the ONU status. If the ONU can registered successfully in the OLT system, it can show you the operation status is activate. And this is the PMT200 PON installation tester features. Through the GPON ONT emulation to extract PON ID and OLT TX power and ONT X power, ODN loss, and ONT activation status. And the operation mode is on the mobile phone app through the Wi-Fi connections. And also this tester supports the OPM and the VFO functions. And the next one is the pro version of the PMT200. We call it FOH200 series. This one can apply in the GPON and the XGS PON. This product PMT200 only can use in the GPON network, but this one XGS PON is also available. What can we get in these testers, like the downlink power and the PON ID and the ODN class and the OLT TX power and the ODN total loss, both GPON and XGS PON. Just the connector, all the GPON and the XGS PON information will be displayed on the mobile phone app. Some features like this: automatically PON ID detections, including OLT PON ID and ODN class, TX power, power level, and ODN link, pass field. And also, it has the downlink 4090 and the 1577 selective optical power measurement testings. And also, this tester supports GPON, XGS PON, and COBO PON network. COBO PON means the GPON and the XGS PON deployed together in the OLT. Bluetooth connection with the mobile phone app. Every operations we can do on the mobile phone app. And it supports a 20 watts quick charger. And the next product is our star product. It's a very nice product. We call it FOH100 GPON testers. This testers is an ideal tool for field technicians to deal with the GPON and EPON network correct installation, activation, and maintenance. It can be seriously connected everywhere in your PON network and performance measurements without configurations. When these testers connect in series in the PON network, the OLT informations like the PON ID, like the TX power, like the OU informations, OU serial number, password, PPOE can be directly extracted. In addition, FOH100 Pro can accurately identify the status of the ONU. If the ONU is online, unregistered, rogue ONU, offline ONU, no ONU, or fiber break, can do the very very clearly ONU status check. Some features of this product: FOH100 GPON testers. The most important function is the ORT and ONU identifications, PON ID, ORT takes power, and ONU serial number extractions. And also, it has supports the PON power meter functions like the 4090 and the 1310 measurements and the certifications. And also, it supports the ONU status identifications. Also, this supports the regular detections. At last, this tester supports the high precision OTDR. It can test more than 20 kilometers. And here we can see some field applications. The first applications is the PON FTTX service activations, ORT and ONU identifications when activate the GPON service. Just connect our testers between the splitters and the ONU, and we can know these informations, ORT informations and ONU informations, and this is the ONU serial number and the password and the ONU PPPoE account. And here is the ONU status activate. And here I show you some basic informations like the downlink power, uplink power, and the ODN total loss. To read these informations to ensure the correct service activities. And the next functions is the PON maintenance and mappings. Because our tester can connect anywhere to get the PON ID and the ONU serial number, so these identifications can help the operators to do the PON resource mapping and organizations to do the PON resource maintenance. After the technicians do the testings, he can make the label on the splitter output fibers. Then he will know which fiber is connected to which users, which fiber port A, a splitter port A is to connect to which user, connect B, output B is to connect to which users. Every output can corresponding to the users' informations. So it will be a good functions to do the PON resource maintenance. Actually, our testers can connect anywhere in the PON network. For example, if the technician connect our tester before the splitters, or before the first splitters at the ORT side, all the online ONU informations, we can see there is all the online ONU informations were displayed on the mobile phone app, like the ONU ID, ONU serial number, and the password like PPPoE accounts. Also, the PON power meter were displayed on the app. Every online ONU information were displayed on the mobile phone app. And also, these testers can distinguish the ONU status, like if the ONU is power on, the ONU status may be online, may be unregistered, may be rogue ONU. If the ONU status is not power on, the status may be offline, maybe no ONU, maybe fiber break. This is the ONU status identifications. Next function is the high precision OTDR functions. This tester has the built-in OTDR functions. Also, this tester can help you to check the fiber link map, fiber quality of the job cable in the last mile. Usually, we can test from the splitter to the ONU. Also, we can test from the ONU to the splitters to check this job cable qualities. the test range, the maximum is 20 kilometers. The dynamic range is more than 10 dB. That zone is 2 meters and 6 meters. So this function is enough to test the last mile job cable quality. This is the screenshot of the OTDR functions. Next product is the FOH200 XGS Pro and FOH200 XGS Max. This is a Pro and this is a Max. These two products is the update of the FOH100 series. Because FOH100 series, FOH100, this testers is for GPON and EPON. This test only for the GPON and EPON test, but this is FOH200. This is the update functions. So this function, this OTDR, this tester can apply for the XGS PON. Can do XGS PON testers. So this tester can apply for the XGS PON tester, can to detect the PON ID, TX power, and ODN class, and also to detect the ONU ID and ONU serial numbers. This is the 200 series. The next part is application layers. In this application layers, we need to test the wired and the Wi-Fi speed test. We call it PMT 800 PDA. PDA means the personal digital assistance. Personal digital assistance in FTTX network. And this tester have a 2.5 gig. And a 2.5 gig internet port. So the wired speed test can bigger than 2 gig. This is a screenshot from the speed test. And also, if you use the Wi-Fi speed test, also bigger than the 1,800 Mbps. This is the PMT 800 PDA features. Here is the 2.5 gig internet cable port, and this is a 1 gig port. There are two internet ports to do the speed test. 2.5 gig internet port to support wired network speed measurement more than 2 gig. And also this one supports Wi-Fi 6 with 160 MHz bandwidth test. And support all class speed test. Okay, this is the PDA, PMT 800 PDA product. And part 4 is the optical network basic tester. Actually, Grandway has a lot of testing meters from the OTDR, from the fusion splicers, from the PON testing solution products like the optical basic test, VFO, laser source, power meters, multimeters, alternators, fiber identifier, and cable identifiers. And also we have some products in the CWDM system testings, CWDM power meter, CWDM analyze, and CWDM OTDRs. And also we can provide a lot of tools like cleaver, like launch cable, like microscope, like fiber cleaner, and so on. A lot of testing meters. And the first part is Grandway fusion splicers. Actually, we have these 3 fiber fusion splicers, 601 and 401 and 601 and 901. Four motors. This splicers is used for the FTTX network, and this is 6 motors. 6 models to achieve the co-alignment. And this is the 2 to 12 core ribbon fiber. This is for the ribbon fiber splice. Actually, Grandway is the sole agent of Fujikura in China from 1997. So we have, and since 1997, Grandway has been as the Golden Prize Maintenance Center in China from 1997 for Fujikura. So Grandway has a lot of experience with these deeper cooperations. We learn from the Fujikura, and we develop our own splicer machines. And also we have a lot of Grandway series laser saws, and this is VFL, and also this is the VFL, and 1 milliwatt to the 30 milliwatts are available, and the maximum test distance can reach to 15 kilometers. And these two products is the red light output, and this two is the invisible. The output wavelength is invisible. The first one is the FH1 series laser source, and the next one is FHS2 series laser source. The output power is minus 5 dBm output. And the next part is the Grandway optical power meters. This is MT500 power meters. And to support power meter, VFL, RJ45, cable sequence test, and the torch functions, 4-in-1. And this is another small series power meters. We call it FHP 12 series power meters. And this is also the FHP1 series OPM, and this is the FHP2 series OPM. We have a very complete power meter family. And also we have some other products like the optical multimeters. The multimeters support the data source and the power meter integrated together. And also the fiber optical attenuators for the fiber attenuator. And here is the talk set. In some areas, the mobile phone communication signal is not good. We can use the fiber resources to do the communication talk on the fibers. And here is the OFI-5 fiber identifiers to check if the fiber is with signal or without signal, and to check the fiber signal transfer directions and the power and the frequency. This is the fiber identifier. And also we have some basic series OTDR, except 5000 series. That one is a very high-end OTDR. And also we have some basic series OTDR like 3000L, 1000D28, and 1000D22. And also we have some new products. We call it Mini 1000 series OTDR. And also we have some microscope products. Here I want to talk to you is only this FIM4 and this FIM18 microscope can work with our 5000 series OTDR, and others can't work with our 5000 OTDRs. It's our microscope product. This one is supports Wi-Fi connections and supports pass field functions on the PC. Okay, that's all for today's simple introduction of our Grandway products. Thank you.